Our home, a massive, complex world. To us, it feels incredibly big. We build cities, cross oceans, and think we've conquered its size. But as soon as we look up, we realize we're part of something much, much bigger. The Earth is a pinprick compared to our sun, and our entire solar system is just a neighborhood. The scale of the cosmos is almost impossible to comprehend. Today, we're going on a 5-minute journey to understand the actual size of the universe. Welcome to A Cosmic Perspective. When we talk about the size of the universe, we first have to clarify one crucial detail. Which universe? There's the part we can see and everything else. Light has a constant speed. This means that when we look at distant objects, we are looking back in time. The most distant objects we can see are from just after the Big Bang. This ancient light, called the cosmic microwave background, marks the edge of what we call the observable universe. Beyond this wall, light hasn't had enough time to reach us. This sphere of observation is vast. Because light travels at light speed, and the universe has been expanding for 13.8 billion years, you might think the observable universe has a radius of 13.8 billion light years. But you'd be wrong. Because the universe itself is expanding, the light from those most distant points has had to travel further as it moved. The observable universe has a diameter of about 93 billion light years. 93 billion light years. To put that in perspective, there are estimated to be about 100 to 200 billion galaxies within this observable range, each galaxy containing billions of stars. This incredible web of galaxies is the known universe. Everything we can detect, from black holes to distant quasars, fits within this bubble of time and light. But here's the thing. We only know about the parts within our horizon. Most cosmologists believe the universe is much, much larger than the observable portion. This brings us to a fundamental question. Is the universe finite or infinite? We are still trying to find the answer. It depends on something called the shape of the cosmos. If the universe is curved like a sphere, it would have a finite size and wrap around on itself. If it's flat, it might be infinite. This depends on how much mass and energy are in the universe. Observations, especially of the cosmic microwave background, suggest that the universe is extremely close to flat. We measure curvature with incredible precision. If the universe is perfectly flat, the math allows for it to be infinite. This would mean that space continues endlessly in every direction, beyond the observable horizon. Even if the universe is finite, the theory of cosmic inflation suggests it expanded so drastically in its first moments that it must be exponentially larger than the observable portion. Some theories go even further, proposing a multiverse where our entire universe is just one bubble in an endless sea of other, separate universes. The true full extent of the cosmos, whether it is infinite or merely trillions of times larger than what we can see, is currently beyond our knowledge. We are exploring the edge of the unknown. It's easy to feel small when we discuss these numbers, but this comparison is exactly why cosmology is so fascinating. It forces a collision between human-scale concepts and reality. We've only been here for an eye blink of the universe's existence. We are a recent addition to this ancient, massive stage. Part of the challenge is that our brains struggle with numbers this large. We can say billion, but we can't truly grasp the difference between a billion miles and a billion light years. Yet despite our scale, we've used science and observation to measure this vastness. Our understanding has grown from simple constellations to mapping the cosmic web. Our telescopes are time machines. Tools like the James Webb are pushing the boundaries of what is observable, showing us even younger galaxies and closer points to the beginning of time. There is immense humility in science. Acknowledging what we don't know, the true total size, is just as important as measuring what we do. It drives us to keep asking, so how big is our universe? We know the observable universe is a bubble of about 93 billion light years in diameter. It contains billions of galaxies and everything we can see. Beyond that horizon lies the actual universe. It is almost certainly vastly larger, perhaps finite but exponentially huge, or possibly infinite. We continue to measure its flatness. This realization changes us. It's not about how small we are, but about the scale of the system we are capable of understanding. The size of the universe is a monument to cosmic scale. As our technology advances, we might one day confirm the flatness of space or find evidence of what lies beyond. The journey of understanding is far from over. If this scale blows your mind, let us know in the comments. Which theory do you find more compelling, finite or infinite? Thanks for watching, and subscribe for more deep dives into the cosmos, leaving you with a perspective from Carl Sagan. From this distance, our entire world is just a pale blue dot, the only home we've ever known in a cosmos that is truly immense.